now on the agenda today, we're going to go over the new guide curve operation, the NX CMM inspection programming modifications, NX tooling design mods, the feature-based machining modifications. Feature-based machining has been around for a while, but excuse me, previous to in version 11, they started doing, instead of you going in and for those who don't know, feature-based machining is where you allow NX CAM to look at the part and identify features, whether that be holes, threaded holes, pockets, 2.5D features. And then there's a thing called feature-based editor, knowledge-based editor in the background that holds all this knowledge, these preconceived operations with tooling, and it'll find those features, and then it will create operations, grab tooling from the library, and then you just have to generate that. But all of the configuration for that knowledge was done through the knowledge-based editor, which is a macro B style programming that is a logical command with variables that are plus or minus variables or if statements, things like that. Now in NX12, what they've done is, instead of having to know that macro B style of programming logic, you can do it directly inside of the operation. You can teach a feature and then give it different conditions and tooling and things of that nature. So instead of having to understand this whole different knowledge base editing system, we can do it conversationally right inside of NX. They've also done major modifications to the simulation side of NX, and I'm going to do demonstrations on both of those. And then I wanted to talk to you about where we're headed with NX CAM or NX in general in the near future. So here, we're just going to talk about the different key capabilities overviews. Most of the add-ons that they've done and modifications were for the mold and die machining industry, the adaptive milling, enhanced finishing strategies, and the smoothing of tool paths. They've also done production machining enhancements with the machine line planner, as I said, the automated CNC programming, which is feature-based programming, and they've also done a lot of cleanup in the mill turn programming to give us more of a seamless operation from chuck to chuck, upper turret, lower turret. The complex part machining to machining, the robotic machining enhancements. In the upper right corner of that, you'll see that that's a turbine, that's an impeller blade, axial impeller blade. That's what the turbo machining operation is for, either the axial or the radial blades. Axial blades are more fan styles, radial blades are more for turbo style blades. Also, they've given us a incredible additive manufacturing module inside of NX for powder bed fusion and HP multi-jet fusions. It's amazing how it has a three-dimensional algorithm for nesting of parts. So it'll give you the build volume, and then at the click of a button, you can do a 3D nesting for however many parts you want, different tolerances, and you can give it a time to, it'll try to do as many different options as possible in that time until it figures the best one out, or it times out one or the other. They also did a lot of work in the CMM inspection programming with the circular inspection point sets that do not raise the probe up for more efficient tool paths. But they've also given you the ability to read in external DEMAS programs, and that goes hand in hand with the simulation. We have the G-code emulator, which it actually runs the G-code and not the NX code, the CLSF file in the background. We all know that CLSF file, it's good inside of visualization, inside of NX's verification software, but there's a big difference between that verification software to where the tool rotates about the part and going into a real life environment where the part stays stationary or sits on the rotational axis and the tool physically moves. So what they've given us is the ability to read in a G-code program or a DEMAS program, give it a real life virtual setup, and then run that program with the tooling to validate it exactly as if Vericut were on board. So what they've done with our CMM inspection module is giving us a much better module to compete with Vericut, and they've done a very good job at that. But going into the simulation module now from 11 to 12, it's a little bit confusing on what they've done and how it operates. So I'm going to go through a demo of that. And last but not least, the tooling design, the automated feature recognition, which is feature-based, and then there's accurate tool costing. I'm going to talk about that a little bit more in depth because the production software that they have inside of NX for doing estimates on tooling design, it's incredible now. So you can be much more accurate and be much more competitive in the marketplace. So first, we're going to start with the guide curve demo. I'll pull up a session of NX, and I already have these parts open. So here we have our guide curve, excuse me. And what I've done is I just pulled out a guide curve operation. So that's in create operation, contour milling, and our guide curve is here, the new fixed axis guide curve. And then they also have a multi-axis guide curve where it's a variable guide. So what it's asking, what it will ask from you is just to give it two guide curves and geometry. So if I choose this, it's all it's going to ask for is the cut area and then for you to identify guide curves. So just for a time's sake, so we don't get into processing too much time, I already have this programmed to where I have selected two guide curves on the part and a cut area. So I've selected this top radius as my cut area. And then in the guide curves, I've selected the top and the bottom guide curves. So it's going to morph between guide curve 1 and guide curve 2. And you see that the arrows are just like streamline, they need to be in the same direction. And then you have your different parameters down here to set. Now, to see this operate, this is going to, I can see that this is going to take place of streamline in a lot of different places because it's much easier to program than the guide curve. So you can see this is just going, and it's going to stay down just as guide curve would, and it's just going to create a nice smooth motion for this toolpath. So it's a nice operation. It gives you good toolpath, and it's easy to control. And it doesn't ask a lot of us as programmers to create it. Just a few selections and to process, and it processes pretty fast. And you can do the same with the variable guide, except you can vary the tool axis about the part. So that was guide curve. Now we're going to get into the feature-based machining. It has improved feature depth definition when it recognizes individual parts. So if you have plate on top of plate and you have a through hole through both of those plates, a counterbore hole at the top plate, threads at the third plate, the depth of that one feature, it would want, instead of seeing one part, it would want to see the whole entire volume. So it identifies different component stacks of what feature you're actually going to machine, whether it's the work part or it's a different part underneath of the work part. So it gives you a much better feature definition, depth definition. Then it gives you enhanced feature grouping capability. And what they're talking about there is once you find the features, you can go to the next step of grouping features. So it groups any like features together so that it's the exact same as creating a feature group. Say you have 100 holes on your part and you have 3 tools on each one of those holes, center drill, drill tap. Well, you don't want to select 100 holes each individual tool. So you would create one feature group with all 100 holes, and then every time you chose a tool, you would just pick that feature group so that it selected all 100 holes. It's the same exact functionality here. It just groups like features together so it's easier for us to program. And then the performance improvements on the parts with a larger number of features, they're meaning the time it takes to do feature recognition, go through the feature navigator, the operation to create the operations and to pull tools from the tool library has grown greatly. The time I'm sorry for processing has decreased greatly from previous versions. They've given the recognition ability either more tolerance, or they've narrowed down tolerancing for features so that it picks them up and programs them much quicker than before. Of course, the benefits to the customer are it creates more accurate and accurate features, and it reduces the NC programming time. So we'll go into the feature-based demo now. This one takes a little longer, but it's extremely worth the demo. So the only thing out of the box, everybody has feature-based programming that has contour machining. So the only thing that you have to do in order to do feature-based programming is label a part, which I've selected the part here, and then give it a blank, and I've chose bounding block. But you see I have no material in Z, so I'm going to make sure if NX does not see material, it will not create a toolpath. So I'm going to go ahead and give it 100 thousandths in Z so that I have material to cut. Now, all we do is we right click in the background here. I'm sorry, we go to Feature Navigator. right click in the background, find features. Now you can see at the bottom of the screen on the status bar, when it's going to do this, it will show you what it's processing. And these are the standard parameters. So we're telling it parametric recognition, search the entire workpiece. And then we have this gray check here in recognition, so that it's checking everything. And these are the different features that it's looking for. So and then you can say limit search area, and you can give it a machining access direction if you would like. So we're going to tell it our machining access direction is opposite to this. So there's our machining access direction. Now we're going to find features, and you see down here, recognizing features 0%. It's going to go through there, analyze and interrogate this part to find all of those features. And this is a step file, so it's our parasolid file, I'm sorry. So when you're looking at a parasolid file, it can still understand and recognize certain features. It won't recognize specific features, and tapped holes become an issue because of the understanding the threads and the pitch and everything like that. But for the most part, it will find all of your features. Now I did make a mistake here, so I'm going to go ahead and close that out. I'm going to change my machining access direction, refine features, so it's on the top of the part. So you see it's finding the features again. It's very quick. Then in this box down here, they don't give you a lot of room to look at it, but these are all the features that it had found. It's even smart enough to say that this feature here has these sharp corners in it, and no end mill could get those. So it's labeled that as a wire EDM shape. So I hit OK. This populates these features. Now I right click on the features again. I hit group features. This will group these features into like categories. So create feature groups. Then I hit OK. Now these two buttons here is feature view and group view. Now when I go to group view, you see now I have feature groups that are going to control the individual features. So instead of going in and grabbing all of this information each and every time, I just grab the feature group once. So now what I'm going to do is I'm going to re-highlight all this information, and then I'm going to right click, create feature process. Now the right clicking method, that will work for everyone, but for a standard ribbon, it's up here in the right hand side of your ribbon. I just don't like it up there, so I've changed my ribbon. This is my custom ribbon here that I do programming out of. Now, after you've created the features, found the features and created the feature groups, it will take you to the next option, which is how would you like this to create the features? And we're going to select rule-based. Rule-based is going to go out to the machining machining knowledge editor, and it's going to pull that logic from the editor. And we want it to do all of these different options for it to be able to program. I removed turning and wire EDM just so I didn't get those options. Any hole that's above a certain size in CAM, it will convert to lathe because of the diameter. So I eliminated turning so it holds milling. Once I hit OK to this, it's going to process all of these different features, and it's going to create operations to do these features. So once this is done, I'll go to my machining navigator, and then it'll show you the operations that have been created. So once it's created, you can see it's very quick. Now I have all the different options. Now I'm going to go ahead and go up to my top level, and I'm going to just generate this toolpath. So now it's running through generating the toolpath. And this is just like any other program. You know, you're going to have to go through and clean up the sequence of operations because there's certain things that you want to do before you do other things. So when we do this, I'm going to go ahead and go to my program order view. And here are all the different feature groups. They've created their own folders. I'm going to expand all these. So this indexable drill here that they want for the larger holes, it didn't generate because it has operations previous to it. So we want this surface to be first. Then we can mill those pockets. We can do them slots. We can drill and then finish. So all of these are in sequence now. Go to the top level, generate. Let this run through and generate those. And in NX12, what it'll show you inside of the messages that what they've stopped doing is they've stopped processing up-to-date paths. So any of the paths that are up to date, it will not process. So going in here, it didn't create a tool. So that's why it didn't grab a tool because of the size. So we're just going to go in here and grab one from the library, insert drill. Now let's go up here and we'll do some analysis. You can do analysis with the dialogues open. So that is a diameter of 75 millimeter. So what I'll do is I'll look for a tool this is the wrong category of insert drills. Now we're going to look for something pretty large. We'll use a 65 millimeter. So now we'll generate. Now everything is going to be in sequence and up to date. And once we do this, I'm going to go and show you the simulation, the verification enhancements. So this is verify. We'll slow this down. And this is where the tool does all the motion parts stay stationary. So they've given you some abilities to suppress the animation just to get times and to show your in-process workpiece. And the modifications done in the verification side of things, the enhancements are truly only speed, processability, and the speed at which it can process the information that it's trying to understand. So not much for visual change inside of this. But you can see I've programmed this part in just a few minutes, and what you can do with this is you can change that, go into the machining knowledge editor and change the way that it processes these features. So if you wanted to keep your carousel of tools for the first 25 tools, exactly always the same exact tools. For an example, I had a customer that's a stamping facility that they do plate work like this constantly. So what we've done is we loaded their machine tools up with 30 tools. All of the drills and taps and common end mills and insert drills are loaded and they always maintain the same tool. So what we've done is we've changed these conditions so that no matter what feature it finds, it will use current tooling to make the feature instead of loading dedicated tooling for a feature. And what we found is they're at least 25% faster doing it with common tooling, even if it's, say, these large 75 millimeter holes. That customer would have a 63 millimeter insert drill and then a 3/4 inch carbide roughing end mill, 3/4 inch carbide finishing end mill. And feature-based machining would pick those tools and generate the operations with those tools instead of the tools that it picks just from the out-of-the-box machining knowledge editor. And by doing that, it makes your plate programming fully automatic. They can do this feature-based programming start to finish, and it uses common operations, common tooling that's already in the machine. They know they don't have to set anything up other than the part. They don't have to put tooling in or anything, and they have guaranteed results of 25 to 35% increase, which is great. And it saves the operator time and the tool crib time of setting up those tools and touching them off and loading the carousel for that. So feature-based recognition, feature-based machining, it can be very, very handy. And to be 100% honest, whenever I do contract programming for Saratech, I don't care what the part is. I always start off with feature-based recognition because it gives me almost all of my features, all of my planes, all of my axes, and it pulls in a lot of common tooling. And all I do is modify and add a few things that I need to add. But I'd say that 50% of the programming that I do, it'll work on 3+2 machining as well. It just won't work on contour machining. It will give me the correct operations, correct tools, and the correct axis and approaches that I need to machine that part without me having to actually create every single operation. I just use feature-based programming, and then I fill in whatever it doesn't find. And I haven't done anything to my out-of-the-box setup. So I just modify tooling and operations as I need to. And it helps me along to make me much more efficient and much more fluid. So let's talk about the additive manufacturing and the 3D printing, what they've added into NX. So they've given us a very strong powder bed fusion module, and you can print 3D and complex metal parts for real production. You can position the parts in the build tray. You can create support structures, define the build process settings, generate printer specific outputs. You can do most of this automatically. It'll create the supports automatically. It will 3D nest your parts automatically. It does a lot of things automatically in the additive manufacturing. Customer benefits, You can leverage the most widely utilized metal additive manufacturing technologies. You can print fine internal details and complex features, and you can print near forged part material properties. So to break that down, what you can do is if you have a part that is going to create a lot of hassle for you to either get casted or to machine it out of raw stock, you can get this part printed, or you can have a printer yourself and print this part. And the properties that we're able to get now out of the materials for the additive is heat treated forged material properties. So you're able to get a forged part without having to go through the forging process, which is an amazing shortcut for our prototype tooling. The printer, the functional plastic parts using the process similar to inkjet. And this is really neat, the HP multi-jet fusion. It's using the processes very similar to inkjet printing, but it's printing plastic. So it's putting very small layers on top of each other, but it's doing this more like a Xerox machine is, positive and negatives. So it's a fascinating process, and I would suggest that you go onto YouTube or somewhere like that, or HP website, and just look up this process. It's very interesting to see where we're going and what they're capable of doing now with these plastic printers. Some of the benefits: you can make parts with high dimensional accuracy that doesn't require secondary operations as metal parts do. You can build 10 times faster, and you can reduce the production costs. So productivity enhancements in XCAM, we've improved the NC programming efficiency, just the way the interface works together with itself. They've improved this efficiency with the ribbon and the way NX is built now, to where we're getting a great efficiency percentage. I don't know that percentage off the top of my head, but the last I saw, we're somewhere around 40%, just in the way NX processes toolpath, post-processing, generating, finding features. Just the way NX is set up to run now is 40% faster than, say, version 10. So here we have some enhancements to machine validation, and they should have really labeled this as machine tool simulation, because I just showed you the verification, and this is the simulation software. So they've enhanced it to display critical information during the simulation, instantaneously start simulating any operation in any sequence, accurately analyze machining times using the machine dynamic parameters. Benefits are reduced programming time, eliminate errors on the shop floor, and optimize the machining process. So let me go in and do this simulation demo for you. And I have this set up on this part here. And what I've done is I've just loaded in a gantry mill. I'll go ahead and turn this on. So this was in the background. So when I turned it on, it didn't outdate my operations. And what it will do if you put the machine tool in last is it will create a red circle with a line through it on all your operations, because it doesn't know how the machine tool is going to rotate its axis joints around to be able to line up with these features. But since I had it in there from the beginning, everything is in tune. Now, when we go up here to simulate, right off the bat, you see that there's a major difference in the way that the simulation is set up. So you can see that everything now, instead of getting a dialog box that says down here the side like this, that says has your simulation settings on it, you get this information box, and then all of your simulation options are on the ribbon. So they've created its own ribbon. So this is the execution view window. So here is your material removal and then your collisions settings. So for this, and then also I'd like to show you, this is machine code-based simulation. This is meaning that before this part is loaded into the simulation module, it goes out, post-processes that code, and then brings that code in, and it physically runs the G code. It does not run, we do have toolpath-based simulation, which is the NX-CLSF file. There's a major difference between CLSF file and machine code simulation. The CLSF file, it's based upon the NX code in the background, which looks very similar to the Siemens 840D control code, but it doesn't take into consideration the machine motion. If there's articulation that needs to be made with say a head machine or a trunnion style machine, it doesn't take that into consideration. Machine code based simulation physically runs the G code. So this is more basically like the Vericut software. So what I'll do is I'll just go ahead and run this for you. We hit play. My speed is set at 10. I'll go ahead and set this to half the speed. And then when I play this, I didn't set some parameters when I created this program. I didn't set tool numbers or speeds and feeds, so it has to have all that 100% correct to run. So right now we're running the face mill. It's slower than verification because it's taking into consideration the machine movements. And then when you watch the simulation, you're physically watching the machine tool run. So the machine tool, all the cycle times, everything would be exactly the same as it would be in real life. And then how they said that you can skip around and do any type of operation. You can skip around and do any operation only in toolpath simulation. If you do G-code simulation, because it has to produce the IPW for an operation that's further down the line, it won't allow you to just pick any operation and run. What it'll do is it will make you create a additional program folder to put that operation in so that it's running from a program folder, because some machine tool simulation kits must have a program folder to have some UDEs listed in it. So you see that this is running, and this is how the simulation has changed. It's all in a ribbon base now. Instead of a dialog base, it's a ribbon base. We have different filters that we can choose for details. So we have a lot of different operations here and filters that we can check to see what's going on. So you see how the machine itself is doing everything that the real machine tool in real life would be doing. And the only way that you can 100% prove out a program is to run a G-code simulation. If you're not running a G-code simulation, then it's not proving out the part as it should before it goes to the machine. So once you run your program through the simulation software and you don't get any error boxes telling you this is an error or you need to change something, then it's physically ready to run on the machine. If you do get an error box that says, hey, this isn't right or this isn't right, you simply just go back to the operation, finish it, go back to the actual operation, change what you need to change, reprocess it, get everything back to date, and then simulate. So it's a very smooth process going back and forth. No jumping out to a different software, third-party software. Everything is done internally, and it's very streamlined, and it's very easy to process through. Little bit getting used to on the new control, the new interface, but once you do get used to it, it's very, very simple to use. Some of the productivity enhancements. I put this in here because this is more important to a lot of customers. I've had customers over the years call in to the help desk line and say, hey, I put in another CPU or another drive into another hard drive into my box, and it doesn't show that I'm using any more of my CPU. Why is that? Well, NX is not a multi-core processing software. They're just starting to come out with the multi-threading support, where it'll utilize much more of the CPU. It gives us faster toolpath creation by 20% and improved productivity, but the calculations that it does for 3-axis and 5-axis operations are much quicker because it's utilizing more of the PC hardware. And this just came out in version 12. The CMM inspection programming with NX, what they've done in this is they've given you feature-specific programming where you can do the feature-based programming on that, and it will give you a CMM program. But what you also can do is if the designer designs using PMI data, it has one button click that says convert PMI to operation, and it will convert every single PMI data that's attached to a feature into a CMM inspection toolpath. So it's very quick, you're able to do feature-based programming just like you are milling on the CMM, and it's just the same. It creates your operations, picks your probes, does everything for you so that you don't have to sit here and create everything individually. So some of the customer benefits to this is you can program circular paths faster with a circular point because it doesn't come up in between features as long as there's clear. So if you were measuring the ID of this part, it would stay at the measurement plane going back and forth instead of coming up, going down, measuring 3 points like it normally does. So you can achieve consistent results and you can program circular paths faster. You can also program the inspection programs much faster using PMI data as well. The inspection programs, you can read the external DEMIS programs. You see on the button here, it says import DEMIS. And this is just exactly the same as the G-code simulation module. It will import in a DEMIS program as long as you have the setup and everything set up correctly as if it were to be ran on the floor, or as if that program was intended on it being set up. You can run a check to see how it's going to perform. Analyzing the measurement data from the sources other than the CMM, you can add NX points to the pool of measurement data if you would like to add a point cloud. It enables analysis of the data from other point-based data sources, such as laser trackers and manual CMMs, and it simplifies migration for legacy software users. So your old programs are going to be easily converted into the new software using these methods. Now, tooling design with NX. This is a very important part of what the modifications in NX 12. It automates the tool costing to accurately determine production cost. This is called NX Feature to Cost, and it's a Team Center product cost management tool. It automates the recognition of features for plastics and stamping parts. The plastic parts check, wall thickness, ribs, opening, undercuts, stamping part checks, bends, cutting, drawing, embossing, and it outputs necessary information needed for the TCPCM cost calculation. The customer value is automated and accurate calculation of tool costing. You can win more orders by quoting extremely accurate, and you can improve profitability because you're not over quoting because you're expecting issues or you just don't see something. You're actually using the intuitive nature of NX to quote your parts for you. And the knowledge that you build into NX over the years is going to be used for this feature to cost. So you build features in NX, the features are recognized through feature to cost. So it's going to give you these spreadsheet style calculations that are going to help you in the long run. So if you do stamping or plastic injection molding parts, this is something I implore you to look into, because it can make your quoting process 50% of what it is today, and it can be 50% more accurate than what it can be today. So 3 takeaways from today's session: the new guide curve operation, the automated CMM programming, feature-based programming, the simulation enhancements, and then NX feature to cost analysis. The next session is Design for Additive Manufacturing. It is Thursday, May 2nd, and the presenter is Edwin Abrahaman. Now, if you're ever ready to take it to the next level, Saratech is a fully functioning engineering service. And we provide engineering services to address your demands for advanced engineering capabilities. We also have our own 3D printers to where we can print parts, plastic or metal for you. And we do all stages of engineering services, from design to CNC programming, CMM programming, support, all facets of engineering. Now, these are some Saratech links that will be put on the website for you to look into. And here are a few Siemens sites that are manufacturing forums, and then the website for you to look at if you're interested as well. So with that, I'll turn it back over to Andrea.
Awesome. Thank you so much. Great job today, Mark. And yeah, lots of content to go over. If you did not receive the recording for part 1, please let us know, or you can go ahead and check it out on our YouTube channel. This one, the recording for today's session, will be sent out to you as well. And if you have suggestions for future sessions, please leave that comment in the survey that will pop up as soon as the session ends. Just let us know how we did today. We're always looking to improve, and we always like to know if we're spot on as well. So thank you all again, and we will see you in just a couple of weeks for Design for Additive. Thanks so much. Talk to you soon.